Good afternoon, everyone. We'll give it about a minute to let everybody join and get in, and then we'll get started here on what you need to know, safety and handling of permanganate. Okay, we'll get started here. So thank you for joining us today for Welcome, What You Need to Know, Safety and Handling of Permanganate. A few housekeeping items before we get started. We are recording this meeting and everyone is kept in listen-only mode. If you have questions throughout the presentation, we encourage you to submit those throughout the presentation using the question pane in the GoToWebinar panel, or you can email us directly. If you submit questions through GoToWebinar, we will receive a report with the question and your contact information, and we can follow up directly after the webinar. I will, if I have time at the end of the presentation, answer some of the questions that we got. Generally, I can't get to all of them, but we will get back in contact with you. If you are interested in receiving a PDF of the slides or a recording of the presentation, please contact us. There is my email address, and it'll also be at the end of this presentation. We encourage you to share the recording within your network. So at this time, I'd like to take the opportunity to introduce myself. My name is Darin Skutt. I am the Quality and Technical Service Manager here at Carus. I've worked here for 27 years, with the last 22 years in the Technical Solutions Group. I conduct laboratory testing and product demonstrations for our municipal customers, industrial and remediation customers, and do work with prospective new customers. Demonstrations can include jar testing, technical training, safety presentations, installation of chemical handling and dosing systems out there in the field for our customers. I am a graduate from Illinois Wesleyan University, Bloomington, Illinois, with a Bachelor of Science degree in chemistry, ACS certified. I am a member of the American Water Works Association, the Water Environment Federation, and the American Chemical Society. To begin, I want you to know that Carus is a member of the American Chemistry Council, the ACC. And as a member, we participate in the ACC's Responsible Care Initiative. The ACC provides broad guidance aiming toward no accidents, no injuries, and no harm to the environment. There are several important principles that form this program, but none more important than to protect the safety of our workplace staff and our customers. Today's safety and handling program is one part of our ongoing safety communication effort. As you can see here on this slide for responsible care, we have a secure facility. We're working to reduce our emissions. One of our big projects was we were able to reduce the amount of water that we use in our plant for non-contact cooling, trying to be energy efficient with our facility. And then, like I said, the big thing here is employee, transportation, process safety, and then our product safety and communication out there to our customers. Carus is an RCMS certified facility. So we have safety goals that we set up every year at our plant and for our field staff as well. Because we want every employee to arrive safely at work each morning and return home safely each evening, we emphasize understanding and practicing chemical safety. Our annual company safety goal is 0 recordable incidents. We want the same for you at your workplace. Training webinars such as this one are part of our product safety communications program, and our goal is to continue to upgrade and improve the information and the way that we communicate with you. Webinars, our website, in-field safety training, all things that we offer to our customers. So today we're covering safety and handling of the Carus permanganate brands. Carus has a wide variety of permanganate products, And this includes in the US, Carus potassium permanganate and Carusol sodium permanganate, along with very other market-specific products. Aquox potassium permanganate is the grade that we sell in the European Union and overseas in Asia. Remox S and Remox L are specifically remediation grades, which have additional testing for metals that we provide to our customers that buy the product. And Liquox is an industrial grade of liquid permanganate. So let's start by reviewing some chemistry, since we're covering both sodium and potassium permanganate today. So permanganate products are available as two different grades. Permanganates are part of a chemical category identified as oxidizing agents. Oxidizing agents are a form of energized oxygen, and they're useful in synthesis and purification chemistries. Permanganates are also considered a manganese chemical because of the manganese in the compound itself. The element manganese is found in the periodic table next to iron in the first row of transition elements. The properties of oxidizing agents and manganese compounds drive the regulations that govern permanganate safe storage, transport, handling, and its disposal. Permanganate products are manufactured, packaged, and delivered in one of these two main forms. Potassium permanganate, which you will typically see is a crystalline solid, which looks the pictures to the right hand of the screen, typically greater than 97% active, and depending on the grade can be 97, 98, or 99. Typically, people would talk about potassium permanganate as a dark purple crystal. As you can see in the top picture, it looks kind of grayish. The main product that's sold is a free flow grade, and the free flow additive makes a kind of a grayish color coating the crystal so it doesn't pick up as much moisture when exposed to the atmosphere. On the concentrated liquid side of things, they'll all be sodium permanganate products. We sell sodium permanganate at both 20% and 40% concentration. Carusol is 20% concentration, and Carusol C, with the C standing for concentrate, stands for 40% concentration. Sodium permanganate will look dark purple, like the picture with the white cap. Regardless of which permanganate product you pick, when you dilute those products down, it will look dark purple to pink as you get to lower concentrations, which is that middle picture that you see there. Now, one thing that's good to discuss is the hazard potential of permanganates, and sometimes it's a little confusing, but it's based on the concentration. So here's a visual aid to help kind of explain this idea. The graph is divided into three zones. Green is low risk, yellow is moderate risk, and red is high risk. So here's what the diagram illustrates. The hazard potential for a permanganate product increases with its increasing concentration. So as we go from a weak solution of say 1 or 3%, where there's a lot of water, as we climb up the scale to 20 and 40%, then you're going to have increasing, and then dry being almost 100%, you can see is the star in the very top part. Typically, when we think of dry potassium permanganate, you're going to make a solution that's somewhere between 1 and 5% by weight. The risk is going to be in that green zone where most hazards are insignificant. Typically, we recommend customers make a 1 to 3% solution, with 3% solution being a 1/4 pound of dry permanganate per gallon of water. Potassium permanganate does have a max solubility at room temperature of 5 to 6%, so you can't get much above that. So obviously there's a lot of water there, basically 95% water to soak up the heat of reaction. As you move up the scale, 20 and 40% sodium permanganate, as changing from potassium to the sodium ion increases the solubility in water. You're in that yellow range. You can have other reactions that can happen moving into that yellow caution zone, and we'll talk about these in the presentation when we talk about the hazards of handling 20 and 40%. Obviously, the most concentrated reaction would be with KMNO4 dry crystals, 97% active, so basically 100% active. And these have the most hazardous reactions when mixed with incompatible materials. In this form, it can initiate fires from coming into contact with different chemical compounds, and we'll talk about some of those reactions in the presentation. The first step of worker safety is knowing the risks. What can hurt you and how can it happen? There are three situations that really define the potential hazards for permanganate use. There is the oxidizer hazard, unanticipated reactions with incompatible materials. This situation is potentially hazardous when concentrated permanganate products are mixed together with a substance that they can chemically react with. Because the permanganate is concentrated, a mixture such as this will generate and release heat. Note, permanganate doesn't react with all substances, only a select group of reactive materials. So one of the things you will see as we talk about storage later in the presentation, storage of permanganate in high density polyethylene totes, drums, or bulk tanks, it's not going to react with the high density polyethylene, so you've got long-term storage there. The oxidizer is really talking about reacting with things like oils and greases or other compounds that will react and generate a heat of reaction. There is an aquatic hazard potential with permanganate. Environmental hazards may occur because of a large release that were to get to a water environment can affect aquatic life. Or if you improperly dispose of and it gets into a waterway, that can also result in the same situation. Finally, there is a health hazard. Regarding human safety, exposure may be a couple different ways. It may be internal by ingestion or inhaling the product, or external such as skin, eye, or clothing exposure when handled due to spills or splashing. Most of the health effect hazards are associated with exposure to manganese dust from everyday chronic long-term exposure, such as in our factory. For most users, short-term exposure issues are more important when sensitive tissues such as the eyes may be exposed and result in injury. Worker PPE is always required when handling permanganate, and we'll talk about that more in the presentation. So how do we get the word out to our customers? Obviously, you're all very familiar with safety data sheets. So communicating the potential hazards, the precautionary actions, specific worker protections, and the remediation options is accomplished through a variety of methods. In addition, such to webinars as this one, the common routes are shown above. So safety data sheets, SDSs, chemical safety reports in Europe for REACH, on the package label, the pictograms on the data sheet and on the package labels, and on the truck with warning placards, and warning placards also on the chemical itself. Now, SDSs now meet a globally harmonized system, or GHS, for hazard communication. There was a drive for consistency or harmonization worldwide so that the information would be similar regardless of what country in the world you were in. It has impacted permanganate, and you have seen a shift in how our SDSs rate things and the placards that you see. The safety data sheet is still our most important safety literature piece. The safety data sheet has been updated many times over the years, and for the most current version, you can reach out to us on our website to request the SDS and download it, or reach out to us or one of our emails to request the most current SDS for the product. Because of the GHS change, this switch signals that there's going to be a standard 16-section format to SDSs that you get from chemical companies. Also, globally standardized red, black, and white pictograms are part of this format, which we will always see on the first page of the SDS, as you can see in the picture there. A safety data sheet is available for crystalline permanganate, potassium permanganate, or any of our other forms. It includes cautionary information as it relates to the dry material, which is nearly 100% active at that 97% to 98% active. When it is stored and handled properly, it is stable and easy to use, but it is an oxidizer, and if the dry powder is mixed with incompatible materials, it will generate heat. Some common materials would be acids, peroxides, combustible materials, organics, metal powders, oil and grease. Some of the most common would be there are oils and greases that are reactive with permanganate. a mixture of an oilant or grease that's reactive along with dry permanganate will start to smoke and smolder and will catch fire. Another common material that you may have at your facility would be antifreeze, ethylene glycol. Ethylene glycol and dry potassium permanganate are very reactive and will catch fire when the two are combined. So those are the things you would want to separate. Under dilute solution, once you've diluted the dry permanganate down, much more stable, much less reactive because there's a much lower concentration. Specifically for potassium permanganate, here are the health hazard pictograms that are required for crystalline potassium permanganate. These pictograms apply to all package sizes, from 5-gallon pails to 330-pound drums to 3,300-pound cycle bins and to bulk. The health hazards are listed as acute toxicity oral, category 4, skin corrosion / irritation, category 1C, serious eye damage irritation, category 1, reproductive toxicity unborn child, category 2, and specific target organ toxicity repeated exposure brain, category 2. If you would like to know more information about each of these specific categories, there is the OSHA.gov website where you can get this. Now keep in mind the numbers are reversed for the pictograms. So typically we think of with the NFPA diamond as the number increases, the hazard increases. The reverse is true with these health hazards. The higher the number, the lesser the hazard. Under physical fat hazards, you will always see the burning circle, which stands for an oxidizer, which is category 2 for crystalline permanganate. Under environmental hazards, you have 2, hazardous to the aquatic environment, acute hazard, category 1, and hazardous to the aquatic environment, long-term hazard, category 1. Because of these environmental hazards, this impacts the quantity of material that may be released to the environment. This only applies to large packages. In addition to the pictograms that you see on the SDS, they're also included on the product label. You will also have the name, address, and telephone number of the company. You will have a product identifier. In this case, here is a label for Carus potassium permanganate technical grade. You will have a signal word for permanganate that is danger. You will see it in red on the label as well and on the SDS. You will have hazard statements that you can see the text below. We'll go through those later here in the presentation. There will be precautionary statements, which you can also see there on the label. And then there'll be supplementary information. For example, permanganate's used in drinking water, so the NSF standard 60 logo is on there, along with the maximum use level for drinking water treatment, along with the AWWA standard for drinking water treatment that you see there as well on the product label. So for potassium permanganate, Carus and Aquox, and Remox S, these are the precautionary statements that you will see on the SDS and on the product label. Prevention: obtain special instructions before use, meaning read the SDS and the safety and handling information. Do not handle until all safety precautions have been read and understood. Keep this product away from heat. Take precaution to avoid mixing with combustibles. Keep store away from clothing or other combustible materials. Do not breathe dust or spray. Wear protective gloves, protective clothing, eye protection, face protection. So the proper PPE, which we'll talk about later. Do not eat, drink, or smoke when using this product. Wash your hands thoroughly after handling and avoid a release to the environment. Under response, In the case of a fire with potassium permanganate, use appropriate media for extinction. If swallowed, rinse mouth. Do not induce vomiting. Immediately call a poison center doctor. If the product is on the skin or hair, take off immediately all contaminated clothing. Rinse skin with water, shower. Wash contaminated clothing before reuse. If the product were to get in your eyes, rinse cautiously with water for several minutes. Remove contact lenses. Continue to wash your eyes for several minutes. If inhaled, remove person to fresh air and keep comfortable for breathing. Under storage, store locked up. Under disposal, dispose of contents container in accordance with local, regional, national, and international regulations. Hazard statements for potassium permanganate. So it's an oxidizer, so it may intensify your fire. Oxidizer, harmful if swallowed, can cause severe skin burns or eye damage, suspected of damaging unborn children, may cause damage to organs, brain through prolonged use or repeated exposure. And this is all to the neat chemical. So switching over to liquid sodium permanganate. So this would be the Carus C, the Liquox, and the Remox product. All liquid permanganates are hazardous chemicals. It is a strong oxidizer, just at 20 and 40% versus the 97% of the dry potassium. It is stable under normal conditions. Same incompatibility list that you saw before, so acids, peroxides, combustible materials, organics, metal, powders, oils, and greases. We do have a second safety caution with the 20% and the 40% sodium permanganate. So because this is a liquid, there is a potential for you to wipe it up with paper toweling or cotton rags at your facility. If you were to wipe up a 20% or 40% spill with a piece of paper toweling or a cotton rag, that permanganate at 20 and 40% is going to react with the fibers in the paper or the cotton rag, and it could start to smoke and smolder and eventually catch fire. So what you would want to do is, if you are going to wipe up a spill, the easiest way is to wet the rag first, wipe up the spill, and then rinse the permanganate out of the rag before you throw it away. Or use materials that are compatible with permanganate, and we'll talk about that more in safety and handling. But there's polypropylene drip pads that you can use that are non-reactive with permanganate. They'll soak up permanganate, you can rinse them out and keep reusing them. So since we switched from dry permanganate to a liquid permanganate, the health hazards have changed. In this case, the health hazard is skin corrosion, irritation, category 1A, serious eye damage, irritation, category 1, and then single target organ toxicity, single exposure brain, category 2. As before, you can get more details on these by going to the OSHA.gov site. Once again, physical hazard for sodium permanganate is going to be the oxidizer symbol. So oxidizing liquids, category 2, sodium permanganate. So how are you going to protect yourself, and how are you going to protect your workers when you're handling potassium or sodium permanganate? Worker safety is one of the most important things you have at your facility. So eye protection must be worn when handling permanganate. As you see, different variations of the protective equipment that you can use. Because of the danger, the decomposition permanganates from permanganate are alkaline and can cause burns that result in eye damage. So typically, if you're not doing a lot of handling, say you're just moving the drum or the tote or a sealed pail of the permanganate around, then we would suggest just safety glasses. If you were to take potassium permanganate and open the pail, and you're going to be scooping the pail or dumping the pail into a dry feeder, and there's now an opportunity for a lot of dust, we would level up to safety goggles so that you have a full seal around your eyes, because in the case of safety glasses, dry permanganate dust could get behind safety glasses and into your eyes, so level up to the safety goggles. You could also put a face shield over top of that depending on exposure. In the case of liquid permanganate, same thing, level up depending on what you're doing. You're moving the liquid permanganate in a drum or a tote, then safety glasses. You open the tote and you're gonna work on a metering pump where now there's a splash hazard. I would level up to at least a face shield and probably up to safety goggles. The other thing that you're gonna want nearby is an eye wash fountain or eye wash bottles, so that if you were to get permanganate in your eye, you can flush your eyes out for a few minutes and then consult a physician if you got permanganate in your eye. So just to reiterate here, dust is the biggest issue with dry potassium permanganate. So this would be the Carus and the Aquox. So goggles would be your best to prevent against dust over safety glasses. If you're handling the sodium permanganate, so Carusol, Carusol C, Remox, or Liquox, goggles would be primary protectors to shield the eyes against liquid or chemical splashes. Face shields could go over the top as secondary protectors intended to protect the entire face against a chemical splash. Now, because we handle permanganate on a daily basis in a variety of forms at our plant, we made a change in our manufacturing facility because we wanted better eye protection. So we use what are called fully sealed safety glasses that have a gasket material that fits tightly to the face. There are many available styles. So what we do at our facility is we have operators test the different styles to see which one will give them the best fit against their face. As you can see in the picture, there is a gray gasket on the back side of these safety glasses, and they fit flush against the face. There are still little gaps to provide some airflow, but they're much closer to the face than normal safety glasses. You can get these specific anti-fogging and prescription lenses that are available. Just keep in mind, these aren't a replacement for working with goggles or a face shield, but for day-to-day use in our plant, we found these are a better way to keep dust out of your eye from a variety of chemicals that they handle in the plant besides just permanganate. There are inhalation exposure scenarios for permanganate products. For the most part, these apply only to the dry crystalline powders. When transferring the material from its package into a storage hopper, a fine dust can be released. This caution also applies to any situation where permanganate is air conveyed, say to a storage silo or transferred by air. Permanganate dust is an irritant and breathing it should be avoided. Permanganate is considered a manganese compound, and inhalation exposure is based on the manganese ceiling value of 5 milligrams of manganese per cubic meter of air, and a time-weighted average of 0.1 milligram manganese per cubic meter of air. So what you can see is we recommend using a NIOSH MSA SH approved dust or mist respirators that are recommended. We use Carus, uses N95 masks like the 3M one that you see there in the picture. Obviously, people are very familiar with these after the COVID outbreak, so very common for people to have these masks or have availability to them. At your facility, you should implement a respiratory program to comply with the OSHA standard if you have concentrations exceeding the permissible levels. This would be if you have some kind of air conveyance system where there could be dust in the area, but it is the customer's duty to determine the risk of dust mist in its application and to protect against that risk. Now, in the case of solutions of potassium permanganate or sodium permanganate, one of the questions we get asked frequently on the technical side of things, is there a vapor or a gas release from a solution of potassium permanganate or sodium permanganate? There is not. Permanganate is a salt solution, so the only thing that would come off of a solution of potassium permanganate or sodium permanganate would be water vapor. there is no permanganate ion that will come off of solution. It may be possible to imagine a situation where you could be exposed to a fine mist of liquid permanganate, and you'd want to protect against that. It would be rare, but one of the ways that it could occur is if you had a metering pump that's under pressure, pumping a liquid product to your application point, and there becomes a pinhole leak or some kind of small leak in the feed line. Because that line's under pressure, you can imagine that permanganate, as the line pumps, product would spray out or mist out of that small pinhole leak, and you would see the purple mist in the air for the permanganate, and obviously want to take proper PPE in order for you to go into that area. The easiest thing would be, before you go in that area and you see that mist, before you go in that area, turn the power off to the pump so there's no more misting in the air, and allow the product to fall to the ground before you go in and work on it. Finally, skin contact with permanganate. Permanganate will react with skin oils, producing a brown stain. Highly concentrated liquid permanganate can attack the skin or other contamination on the skin. One of the most common things that we hear about is someone was working on a pump or a piece of equipment. They got oils or grease on their hand. They then started to work on something that had permanganate. The oil and grease was reactive with the permanganate, and their hands started to get warm, and so they had to go immediately wash their hands at that point in time. So gloves should be worn when handling permanganates. We use chemical resistant PVC or Teflon coated gloves. You should not use cotton gloves. Like I said earlier, permanganate's reactive with cotton, so it could start to smoke and smolder or catch fire. So you'd want to avoid those types of gloves. Nitrile lab gloves are also commonly used so that you have more finger dexterity, or especially if you're working in the lab testing with permanganate. If the level of exposure would be significant, like the delivery of bulk liquid permanganate, then an apron should be worn to limit exposure in case of a leak, like you see in the picture. If you get permanganate on you, you should immediately remove it, as the products can be corrosive to the skin. If you intend to do non-job routine work at your facility with permanganate and you think there might be a risk of exposure, you should complete a job safety analysis to assist in establishing risk mitigation plans to reduce exposure. This could include leveling up PPE or trying to find a different way to complete the task at hand. So at your facility, you'll have a lot of routine handling of permanganate. If you're going to do something out of the ordinary, like you're transferring product from one container to another and it's not something that you do on a routine basis, then you want to sit down and have a review. One thing that I have commonly seen with liquid permanganates is that customers will pump the heel out of one container into the next container. Well, you're using a transfer pump in a lot of those cases that's not anchored. So you want to make sure that when you're using that transfer pump, you have a good way to anchor that tube into the new container. Make sure that you have enough volume so that you can transfer that amount out, because there's an extra splash hazard. So typically, if I was in the field and doing something like transferring from tote to tote or drum to drum, then that would be something where I would wear a face shield, I would wear goggles underneath it, and I would wear a splash apron, because there is a chance for splashing, because it's a non-routine thing where you're transferring from one container and moving them around. I think this should go without saying, but do not eat or drink permanganate or any other concentrated chemicals that you may have at your facilities. Always wash your hands before eating, drinking, or smoking after handling permanganate. If permanganate was swallowed, it may cause severe burns to the mouth, throat, esophagus, and stomach. If permanganate is swallowed, immediately rinse the mouth and drink plenty of water. Never give anything by mouth to a victim who is unconscious or is having convulsions. Do not induce vomiting. If vomiting occurs, keep the head low so that stomach content doesn't get into the lungs. Get medical attention immediately. Refer to Section 4 of the SDS. Storage requirements. Both dry potassium permanganate and liquid sodium permanganate are stable under normal conditions. What that means in the case of dry potassium permanganate, it has a shelf life of indefinite. So a year from now, 3 years from now, 5 years from now, dry potassium permanganate will still be the same 97% active as the day that it was produced. One thing to keep in mind with dry potassium permanganate, if it's exposed to the atmosphere, it can pick up moisture from the air and it will get lumpy and clumpy over time. So you do want to keep it in sealed containers. In the case of the 20% and 40% sodium permanganate, it is also stable under normal conditions. It will be 20% and 40% active today, a year from now, 2 years from now. Typically, we recommend customers change over liquid every 2 to 3 years, but it does not lose strength over time. To give you a good comparison for permanganate versus other compounds that you may have at your facility, sodium hypochlorite, which comes in at 12.5% typically concentration, will lose concentration over the course of a couple of months and might go down to 10%, 8% concentration in a few months. Whereas permanganate is going to stay at 20 and 40%, or the dry at 97% during the course of that whole time and for many years. You want to keep the product dry and away from heat sources, especially the dry for the potassium permanganate, because it will pick up moisture from the air, so keep it in the sealed containers. Do not store next to acids, peroxides, combustible organics such as brake fluid or antifreeze, metal powders, or other materials that are identified on the SDS. You want to take care to protect the containers from physical damage. You don't want leaks of both dry or liquid permanganate, so try to not damage the container. Some of the additional hazards: permanganate can react with hydrochloric acid, resulting in chlorine gas as a byproduct. So you'd want to keep concentrated dry permanganate or liquid permanganate away from concentrated hydrochloric acid. Permanganate can react with concentrated sulfuric acid, forming manganese heptoxide. So you would want to prevent those from mixing. Oils and greases, we do have a list of oils and greases that are compatible with permanganate that you can use. Other ones may not, that are not on the list, may not be compatible, so you'd want to separate those. And I mentioned earlier, antifreeze is a big one. Antifreeze plus permanganate will catch fire immediately, so there's a concern with handling and storage there. So typically, permanganate is an oxidizer kept in completely separate storage or separate containment. Can be in the same building as other chemicals, but separate containment. On another note that's related to product storage and handling, we receive many questions about equipment, pipes, gaskets, tank materials that can be used when storing and feeding permanganate products in the field. We have prepared guidelines and suggestions for compatible materials for each permanganate product. So the picture here is for a Carus potassium permanganate one, and there's also an additional one for Carus sodium permanganate. These guidelines are based on our experiences in our manufacturing plant, from published references by materials and equipment suppliers, from lab tests that we have conducted, and most importantly, from customer experiences from using certain products. New materials are always developed, and if we are not familiar with them, we can run some simple tests to determine short-term acceptability in our lab. One word of caution: common materials can be sourced from many different manufacturers, and they can be produced in many different grades. A particular product may work well in one case for a material, but poorly in another case from a different manufacturer. Piping standards and material standards have been established. We have also designated a list of compatible oils and greases that are used in our plant and on our feed equipment when we produced it. So this is something, depending on the product you're going to use in the field. Please request it for us. It gives you some guidelines to use. Like we said, there are some manufacturers that are good, some manufacturers that are not so good. So they are listed on our sheets for the ones that we recommend that you might use. Thermal stability of permanganates. Permanganate's an oxidizer, so permanganate will decompose upon reaching the temperatures listed below based on this equation. So permanganate is the MnO4-. As it starts to break down, you'll get MnO4 3-, MnO4 MnO2, and then finally oxygen. So in the case of dry crystalline permanganate, decomposition starts at 302 degrees Fahrenheit. It'll start giving off its own oxygen to support the fire. In the case of liquid permanganate, decomposition may start at 275 degrees Fahrenheit, so it'll start producing its own oxygen at that point. So one of the things to keep in mind, permanganate's an oxidizer, it's giving off oxygen. So fires involving permanganate are going to be put out by water. Foams work by smothering it and not getting oxygen to the fire, but since the product itself, permanganate's giving off its own oxygen, foams are not a good way to fight fire with permanganate. You would want to go to water. And fire departments know this. The National Fire Protection Association developed this communication diamond to provide valuable information to first responders, especially firefighters. If a chemical is involved in a fire, it signals how products may react, what the effects of byproduct formation are, and how the chemical might react with water used to extinguish a fire. The NFPA hazard code regarding health hazards, fire hazards, reactivity hazards, and a special white identifier. The numbers range from 0, little hazard, to 4, highest hazard. So specifically, the NFPA hazard code for potassium permanganate under GHS has changed. The numbers have gone up. So the health hazard for potassium permanganate is a 3. The flammability hazard is a 0. Non-flammable, will not burn, but will support combustion by giving off oxygen. And the reactivity hazard is a 1, normally stable, not reactive with water. So that's why you can use water as a fire extinguisher. And then always in the special hazard OX for oxidizer. So the 3 is one of the numbers that has gone up under GHS, and this reflects irritating byproducts that may be formed during a fire with permanganate. The NFPA hazard code for sodium permanganate. The health hazard is a 3. Under fire conditions will give off irritating combustion products. Flammability hazard is a 0. Non-flammable, will not burn, but will support combustions. The reactivity hazard recently changed in 2025 from a 1 to a 2. So it's still normally stable, not reactive with water, but there is a concern from reacting liquid permanganate with cotton rags and paper toweling. So the reactivity hazard did go from a 1 to a 2. And then the special hazard is OX for oxidizer. So the fire department comes upon a scene. They know permanganate's involved, whether it's potassium or sodium permanganate. They see the NFPA diamond. What they're going to know is to use large quantities of water to extinguish fires related to permanganate. You're going to want a berm to contain the water. Obviously, as you're putting out a permanganate fire, permanganate's going to end up in the solution. So you're going to have purple to pink colored water, and you want to prevent that from getting outside the environment into a waterway. So berm to contain it. Do not use dry chemical extinguishers such as CO2, halon, or foams. Those all work by suppressing oxygen to the fire. And since permanganate's giving off its oxygen during the fire, it won't put the fire out. These are all covered in Section 5 of the SDS. Dry permanganate spill up. One of the things to keep in mind is do not move or transport a leaking potassium permanganate container until the leak is contained. So you've opened a pail, you've opened a drum, it may be leaking. Rather than moving the container with product where you would spill it throughout your facility, you want to be able to contain that product. So containment may include patching a container for temporary movement, taking that container and putting it inside a plastic containment pallet or an overpack container. Keep in mind, permanganate's reactive with cardboard or chipboard or other combustible materials, so plastic is your best bet. High density polyethylene overpack, polyethylene, polypropylene overpack would be all good ways to contain the product. So contain the product before you move it so that you don't have a spill of dry permanganate throughout your facility. Anything that were to hit the floor, Clean it up immediately by sweeping or shoveling the product into a separate container. Keep in mind, permanganate is drinking water grade, but once it hits the floor, it could have other stuff that it picks up from the floor. You wouldn't want to have any of those chemicals or dust that's on the floor go back into the original container, because then you might put it into drinking water itself. So you want to transfer anything that you spill to the floor to a clean metal drum and dispose of according to approved local regulations. Dilute permanganate solution spill cleanup. So you're going to want to contain or isolate the liquid either in a pit, or if it's not in a containment area, in a holding area with berms. You're going to want to dilute the solution. So if you're using 20 or 40%, you're going to want it to dilute it to less than 6% before you neutralize it. Neutralization of the liquid permanganate can be using a solution of sodium thiosulfate, sodium bisulfate, or a ferrous salt, or we'll talk about the vinegar and peroxide solution here in a few slides. Now, we in our facility and have customers that have found the following materials that have been tested, and we use in our facility that are compatible with 40% liquid permanganate. There are pig hazmat absorbent socks made out of polypropylene. There are Spilltech absorbent pads made out of polypropylene, and there are United Absorbents polypropylene absorbent pads. Polypropylene is not reactive with permanganate. Depending on the type you buy, they'll have different color codes. Some of these pads will be gray, some of them will be yellow, some of them will be blue that I've seen in the field. The one thing you want to check for is material that they're made out of. Will list polypropylene as what they're made out of, and that is not reactive with permanganate. So you could use that absorbent sock or that absorbent pad for spills of 20 and 40% permanganate, and they're not reactive. If you were to get permanganate in a spill, water is always the solution. Never neutralize a concentrated solution or the solid dry material. You're going to want to dilute the permanganate to less than 6% before attempting any type of chemical neutralization, because you're going to have a heater reaction. In the case of the 20% and 40% sodium permanganate, do not wipe up spills, clean up drips or leaks, or wipe down equipment with a dry paper rag or paper toweling or a dry cotton rag. Have a bucket of water available, wet the rag with water, wipe up the spill, continue to keep wetting the rag to dilute it. Permanganate is going to be very apparent. Permanganate will be purple to pink. Once there's no more permanganate in that rag or paper toweling, it will rinse clear, which means there's no more active permanganate, there's no more hazard at that point, and then you can dispose of the rag or the piece of paper toweling after it's rinsed completely clear. You could also neutralize or put cleaning solution at a lower concentration in the water for your rag too as you're wiping up the spill. One additional thing that we like to point out to customers, never place garbage in a container with permanganate. It's very easy at your facility. You have permanganate. Permanganate comes in metal drums and plastic 5-gallon pails. Permanganate's an oxidizer. People like to use 5-gallon pails. They like to use 330-pound metal drums as garbage containers. And so they've got a container that has had permanganate in it. They haven't cleaned that container itself, so there is still permanganate dust or permanganate liquid still possibly in that container. And then they start to use it as a trash container. Well, you've got the perfect situation to get stuff in there that's going to react and start to smoke and smolder and catch fire. So what you want to use, if you're going to use a container that's contained permanganate first, you're going to want to rinse it until there's no permanganate residual left, and then remove all the markings on the container so it doesn't say that it contained permanganate at that point in time. It's clean, and then you can use it as a garbage bucket. Also keep in mind, if you do wipe up sodium permanganate with cotton rags or paper towels, the last place you want to throw them into is to a trash can with other combustible materials, because it can smoke and smolder, and if it catches fire, the other things that are in the trash can can start to burn too as well. So just keep in mind, while the containers of permanganate come in make great trash containers, you want to clean them before you use them. and remove those markings and make sure that you keep permanganate away from normal trash containers. In the case of permanganate neutralization, like I said, you can use sodium thiosulfate and sodium bisulfate. Both are available as dechlorination agents in both dry form and liquid form. If you are to buy the dry form of those products, I would mix them into water first to make a solution. And then once you have the solution, you can use it to spray and neutralize a permanganate spill. Like I said before, we always want to dilute concentrated permanganate. So if you're buying 20 or 40, dilute it with some water first to less than 6%, and then you can neutralize it at that point. What you will see when you neutralize permanganate solutions, the solution will be purple to pink, depending on concentration. As you react with the sodium thiosulfate or sodium bisulfite, it'll go from purple color to brown, and there'll be some solids generation, which is manganese dioxide, which you see the brown color in the picture. As you continue to apply neutralizing solution, it'll go from that brown sludgy color to a clear solution. As you can see in this picture, there is some little white bubbles that are forming. That's from the reaction with the permanganate and the neutralizing agent. So that is one of the reasons you want to keep the concentration low, because if it's more concentrated, that can generate a heat of reaction. If you've ever handled permanganate, you know that as much as you wear all the proper PPE in all the ways, it is possible to get permanganate on yourself or on your equipment where you want to clean it up. One of the easiest ways to clean it up is with a weaker cleaning solution that's 1/3 part water, 1/3 part white household vinegar, and 1/3 part 3% hydrogen peroxide. Mix those three things together. You can use this on rags or towels to wipe up small spills that are lower concentration. You can use this to clean up your hands as well after you've washed with soap and water. You don't want to use this on sensitive tissue. So don't spray this neutralizing solution in eyes, mucous membranes, open wounds or burns. I can tell you it's vinegar and peroxide. So if you have a nick or a cut or a scrape on your hand, it's going to burn when you put the vinegar peroxide on it. Do not add this directly, once again, to concentrated permanganate solutions. You want to dilute first to less than 6% with water, and then use the stain removing solution at that point in time. All of those chemicals typically available at your local grocery store, your local pharmacy. So in the United States, domestic shipments of hazardous commodities over the highway are governed by Title 49 Code of the Federal Regulations. Specifically, for hazardous materials transportation, it identifies and classifies the hazardous materials. It establishes quantity limitations. It specifies the proper packaging. It describes how to mark and label the package for the product. It defines what shipping certificates need to be with the truck driver, and it details how to placard the vehicle transporting the shipment of the chemical. So specifically for both dry and liquid permanganate. So if you're getting a shipment of dry crystalline potassium permanganate, it has a specific UN number 1490. It has a reportable quantity for a spill or release to the environment of 100 pounds. And the truck will have the oxidizer 5.1 displayed on the side when it's making a delivery of this product. If you are getting a delivery of liquid permanganate, typically it's going to be sodium permanganate, but they list it as inorganic aqueous solutions. It'll have an ID number of UN 3214. Liquid permanganate does not have a reportable quantity established yet. And it will also have the same oxidizer 5.1 symbol on the truck making the delivery to your facility. Now, why does permanganate fall under hazardous materials? So the Resource Conservation and Recovery Act of 1976 establishes 4 characteristics for hazardous waste. It can be ignitable, corrosive, reactive, or toxic. All oxidizers are hazardous under the ignitable waste characteristics, and potassium permanganate is specifically listed by name under this act. In addition, the Comprehensive Environmental Response, Compensation, and Liability Act, CERCLA 1980 Superfund Act, has crystalline or liquid permanganate released to the environment must be reported if it exceeds the reportable quantity. Specifically, dry potassium permanganate has a reportable quantity of 100 pounds. What this means is this is a release to the environment outside your facility. So this question comes up quite frequently. If you're at your drinking water plant, your wastewater plant, or you're at a remediation site and you have a spill within your containment, you could spill 100 pounds, 200 pounds, 500 pounds. It's inside your containment. That is not a release to the environment. That is not a reportable quantity. If your containment breaks and you now have a release on your facility and it goes to a floor drain that then goes to a river, if it goes over 100 pounds, that's a reportable quantity to the environment. If during transport from our facility to your facility on an over-the-road truck, the truck were to have an accident, the containers were to break on the side of the road, there's a release to the environment, to the ditch. If it's over 100 pounds, it's a reportable quantity. In the case of liquid sodium permanganate, whether it's 20 or 40%, there is still no reportable quantity established. Obviously, it's an oxidizer, so you want to take proper precautions for cleaning up the spill, but there is not a reportable quantity for liquid sodium permanganate that's been established. If you were to have a release to the environment outside your fence line to the environment, you'll want to call the National Response Center. It's listed on the SDS, also listed here with the 800 number. Disposal of product containers. Permanganate is considered an ignitable waste for disposal. So disposal should be completed through a licensed disposal company if you're going to dispose of a large quantity. There are alternative uses that can be recommended. We have customers that are drinking water that may have spilt some permanganate into their containment. Since it's hit containment floor, they don't know what else is on the floor. They don't want to put it back into the container and use it. They will give it to the wastewater plant because permanganate's used in wastewater for sludge odor control. In drinking water, we might use 1 to 3 parts per million of permanganate. In wastewater, they might use 25 parts, 50 parts, 100 parts, depending on how much sludge handling they're doing for odor control. As far as the containers, like I said, if you're going to reuse the container, packaging must be triple rinsed to an absence of pink color. So flush it with enough water so there's no more color left behind. And then mark out or remove the label prior to proper recycling or disposal. Like I said, a lot of our customers like to reuse these containers. So you want to make sure you've cleaned all the permanganate, removed the labeling prior to using it for a trash container at your facility. So make sure you follow all that. One question that we get asked all the time. Permanganate containers are designated as single use and they cannot be returned or refilled because of the oxidizer. So when a container has been emptied, in this case, you see a tote, there are companies that will collect them and recycle the plastic or the metal frame. In the case of permanganate, we get this question all the time. Empty really does mean empty and rinsed with water. So if you are using a drum or a tote, you're going to want to transfer the last little bit of product out of the tote or drum into your other container and then rinse that container prior to sending it out for recycling. There should be no pink visible in the rinse water or the container, and you can flush it through the lower valve. So like in the case of a tote, there's a lower valve that you can open so you can rinse the water out. What you want to do at your facility, select a site where you can rinse the container and collect the waste to neutralize it prior to discharge. Or if it's wastewater plant, obviously you can use it for odor control and flush it into your system for odor control. We work with many different tote recyclers to pick up totes. They usually have a minimum quantity of 8 that they need to pick up that are rinsed and cleaned and ready to go, but they will come and pick them up free of charge. One thing that we always recommend, customers should audit their safety and handling procedures for permanganate at their facility to ensure that they are up to date and the most current. Reach out to us for the current SDS and data sheets or any additional information that you feel you don't have that you might need. For SDS, other technical information, you can contact your regional sales account manager, a technical solutions team member. You can go to our website to look up SDSs and data sheets there as well, but please reach out to us. One of the things that we always find when you're doing safety training at a customer site that comes up frequently is they have an out-of-date SDS. So just reach out to us once a year to see if there's an updated SDS. We'll flag it on our website sometimes too as well, so that you can see that there's a new SDS available as well. With that, there is my contact information. Our corporate product stewardship, so she updates our SDSs and makes them available. She's another great resource, Shelly Corbin. So there's our phone numbers, there's our email addresses. You also have an 800 number you can reach, our sales and marketing email, and then our website that you can get additional information. So with that, just checking to see if we have any questions. And I don't see any questions at this time. So like I said at the beginning of the presentation, thank you all for your time. If you have any questions, want a copy of the slides, want a copy of the recording of this training, please feel free to reach out to me directly and we can get you that information. Thank you for your time.